Hi everyone. So today I have a really interesting problem for you, and we're gonna go over polynomial equations. To be more specific, today we're gonna cover a very important problem-solving method in polynomial equations, and you'll see what that is later on in the video. So without wasting any time, let's get started. This is the problem number 11 from the AIME in 2016. And in this video, we're going to be learning how to solve polynomial equations. We're going to maybe look a little bit about the periodicity of polynomials. We have then book suggestions for the AMC and AIME. And at the end, a similar but challenging problem.
This video is sponsored by Cheenta.com. Since 2010, Cheenta has trained thousands of students from all around the world in mathematical Olympiads, physics Olympiads, computer science and informatics Olympiads, ISI CMI entrances, and research projects for school and college students.
Okay, so what have they given us? So let Px be a non-zero polynomial such that x minus 1 times p of x plus 1 is equal to x plus 2 times p of x for every real x, and p of 2 whole square is p of 3. So find the value of p of 7 by 2, right? So let's just go with the substitution strategy, maybe substitute some simple values like 0, 1, minus 1 and see what we get, right? So what I'm going to do is I'm going to put x equals to 1 in the given polynomial equation. X minus 1 times p of x plus 1 is equal to x plus 2 times p of x. And when I do this, I'll get 0 on the left hand side. So essentially that means that p of 1 is 0. That's very important actually. Now if I plug in x equals to 0, I will get minus 1 times p of 1 is equal to 3 times p of 0. So essentially p of 0 is also 0, right? So we can essentially get that p of 0 is also 0. Now the third thing that I'm going to do is maybe put x equals to minus 1 over here, and let's see what we get. We'll get minus 2 times p of 0 is equal to 1 times p of minus 1. So again, p of 0 is 0. So p of minus 1 is also 0. So now what we can do is we can essentially write p of x as x times x minus 1 times x plus 1 times some polynomial q of x. Why can I do that? Well, we essentially got three results, right? P of 1 is 0, p of 0 is 0, and p of minus 1 is also 0. If you just put in 0 over here, p of 0 is 0. If you put 1 over here, p of 1 is 0. And again, if you put minus 1 over here, p of minus 1 also is 0. So hence essentially we can write this, we can simplify the given equation like this. And initially in the problem it was given to us that x minus 1 times p of x plus 1 is equal to x plus 2 times p of x, right? So what would p of x plus 1 be? Using this equation number 4, what would p of x plus 1 be? That would be nothing but x plus 1 times x plus 2 times q of x plus 1. And if I just substitute this back into this original equation, I'll get x minus 1 times x plus 1 times x plus 2 times q of x plus 1 is equal to x plus 2 times p of x. And p of x is x times x minus 1 times x plus 1 times q of x. And let's just see if we can maybe cut certain terms over here. These and these also get cancelled, and x plus 1 also gets cancelled. Essentially we see that q of x is equal to q of x plus 1, right? Now what can we talk about this? Now over here I can eventually I can just instantly conclude that q of x is a constant. Q of x is c. And why is that c? Because q of x cannot be periodic, right? Q of x cannot be periodic. A polynomial cannot be periodic as it is a polynomial, right? Since it's a polynomial. So because it's a polynomial, it cannot be periodic, and therefore it has to be a constant, right? It has to be a constant function, it has to be a constant polynomial. So essentially q of x is equal to c. So therefore I can write p of x, which was essentially x times x minus 1 times x plus 1 times q of x. I can essentially write p of x as c times x minus 1 times x plus 1. Okay, and it is given to us that p of 2 whole squared is equal to p of 3, right? Now if I just plug in p of 2 and p of 3 over here, I'll get p of 2 is equal to 2 times c times 1 times 3, which is 6c, And if I plug in P of 3 over here, I get 3c times 2 times 4. So P of 3 is 24c. Now 6c whole square is equal to 24c, or in other words 36c square is equal to 24c. So that would be c squared, 3c squared is equal to 2c. Now so c can be either 0 or it can be 2 by 3. Now as c is 0, right, so we just diverge it into two cases. Case 1 is c is 0, and if c is 0, then p of x would also be 0, right, because p of x was essentially nothing but c times x minus 1 times x plus 1, right? But they have specifically given to us in the problem that p of x is a non-zero polynomial. It's non-zero, so this case essentially is eliminated. Then we move on to case 2. What is case 2? C is equal to 2 by 3, right? And if c is equal to 2 by 3, then that means that we have formulated the value of p of x. P of x is 2 by 3 times x minus 1 times x plus 1. And they just asked us to find the value of p of 7 by 2 in the problem. So just put x equal to 7 by 2 over here. You would get 2 by 3 times 7 by 2. 7 by 2 minus 1 is 5 by 2. And 7 by 2 plus 1 is 9 by 2. Just maybe simplify a little bit. So you will essentially get 105 by 4. So P of 7 by 2 is 105 by 4, and that is the conclusion of our problem. So I really hope you enjoyed that, and the takeaway was that maybe to essentially, whenever you start with any polynomial equation or functional equation, maybe just start with simple substitution, right? And maybe kind of formulate the value of a polynomial p of x. And here, as we found out the value of p of x, it was actually a constant, as it cannot be periodic, right? A normal polynomial cannot be periodic, right? Okay, so we have some book suggestions for the AMC and AIME. Mathematics Can Be Fun by Yakov Perelman. Mathematical Circles, The Russian Experience. Algebra Can Be Fun by Yakov Perelman. Excursion Mathematics, Challenges and Thrills of Pre-College Mathematics, and Elementary Number Theory by David Burton. Right, so at the end we have a similar but challenging problem. This is a relatively easier problem, and we need to find all polynomials p of x such that p of x plus 1 times p of x minus 1 is equal to p of x squared minus 1. So essentially, maybe you just need to find out the non-constant polynomial, because if you kind of observe this, probably p of x equal to 0 and p of x equal to 1 are the trivial solutions to this problem. But okay, anyways, I'd like you to go over this. I'd not give too many hints because that would be probably giving out too much. And yeah, if you're able to solve it or make any progress on it, please let me in the comment section. And until then, I'll see you in the next video. Thank you very much. Bye-bye.
The programs are designed for students who are passionate about mathematics, and they are personalized with one-on-one training, individual evaluation, and remedial sessions. The reason Cheenta students are successful over the last 10 years because they are taught by mathematicians and real Olympiads from leading universities in India, United States, and Europe. Some of our students come back to teach at Cheenta from Oxford, Cambridge, Harvard, MIT, UCLA, ISI, CMI, IITs, TIFR, and IISc. For more information, visit cheenta.com.